Comparing angles. Chapter 4. Using different methods to compare angles. The learning goals for today is knowing how to compare angles and estimating them, and learning how to use the angle bisector theorem to solve angle word problems. Let's get started. Here's the first section, comparing angles. Let me first ask you a question. How do you think these two angles should be compared? Well, of course, we have our protractor, so we could just measure these two angles. And then we compare them. Which one is larger, which one is smaller. Or we could overlap them on top of each other. This might not be so aligned, but I think you get the main idea of how you can put them together just to find which one is larger, which one is smaller. Not always having to find the exact estimate. The exact value. So here's a conclusion. Angular comparison methods, measuring directly and stacking figures. Here's stacking figures. To compare these pairs is if the ray O prime C, coincides with ray OB, then angle DO prime C is equal to angle AOB. Let's try another one. We're going to compare these two angles. If ray O prime C is outside angle AOB, then angle DO prime C is greater than angle AOB. And another one. If ray O prime C is inside angle AOB, then angle DO prime C is less than angle AOB. Here's some discussions. 1. Is the size of an angle related to the lengths of the rays on both sides? So the answer to this question is no. Because an angle, let me draw a picture. Here, for example, we have an angle. And these are rays. I'm going to add arrows just to emphasize that. The angle, when we measure an angle, what are we measuring? It's the space in between. The size of an angle is the space in between. Because a ray, it extends on forever, on one direction and never ever stops. But it doesn't matter because it's a ray. A ray keeps going on forever and you can't stop it. So, no. The answer is the size of an angle is not related to the length of rays on both sides. 2. A third-degree angle can be viewed with a magnifying glass that can magnify 3 times. What is the change in the new view? What did you think about this? Did you say 10? 30? Well, the correct answer is, for those of you who said still 30 degrees, you were correct. Let me draw another one. This is, say, a 30-degree angle, right? A 30-degree angle with rays. Now we're going to take a magnifying glass. And we're going to magnify over here so we only see this part. But did the size of that angle change? No, it didn't. It's almost like cutting off some rays. But remember, the rays doesn't matter. The angle will still stay the same, no matter if you zoom in or zoom out, if you cut out the rays or not, because, you can never cut out a ray. They'll keep going. Here's example 1. According to the picture below, answer the following questions. 1. Try to compare the sides of angle AOB, angle AOD, angle AOE, angle AOC, Try to find the acute, right, obtuse, and straight angles from them. And 2. Find the 3 equivalent values of the angles from the figure. Did you have an answer? So, the first problem is trying to find the size of angle AOB, AOD, and AOE, and AOC, and trying to find which one is the acute, right, obtuse, and straight angle. Well, let's just look at each of these angles. First, we have the angle AOB. Angle AOB is this angle right here. Well, it's 180 degrees, meaning it looks straight. So it's 180 degrees and it's a straight angle. So that means that AOB is the straight angle. Oh, and by the way, when you're answering a question, you can't just circle these in different color, in the same color as me. You have to write out a clear explanation, a clear answer below the problem, but I'm just doing this because it's easier. Then we have angle AOD. Well, which one is it? Let's look at AOD. AOD. So we know that angle AOB is a straight angle, so it's 180 degrees. And we know that DOB, a section of it, is 90 degrees. And AOD is the other section of 180 degrees. So all we have to do is 180 degrees minus 90 degrees, which is 90 degrees. 90 degrees is a right angle. So that means that AOD is the right angle. Now we have AOE. I'll use blue for that. AOE, let's look at AOE. AOE is this one. But we already know that AOD is 90 degrees or right. So if it's less than right, as you can see, it doesn't line up with OD right here. It's slightly tilted so that it's less than 90 degrees. 90 degrees that's less, well, that's acute. So it would be the acute angle. Last one, angle AOC. I'll use red for that. Red, we have angle AOC. In AOC, it's larger than 90 degrees, so the answer is obtuse. Now we have these matching pairs. We're not done. There's still question number 2. Find the 3 equivalent values of the angles from the figure. First, I'm just going to erase all this stuff. Okay, the 3 equivalent values of the angles from the figure. Well, first, angle AOB is a straight angle. Angle AOC is obtuse angle, and angle AOD is a right angle in it. Yes, that's the answer. So, what does this say? It's angle AOB is greater than angle AOC, which is greater than angle AOD, which is greater than angle AOE. Here are the equivalent values. Angle COE here, COE is equal to EOD. COE is equal to EOD plus COD. Angle AOB is equal to 2 times AOD, which is also equal to AOE plus BOE. DOB is equal to angle COD plus angle BOC. Now we're getting to the angle bisector theorem. Observe and think. Activity. Draw an angle on a piece of paper, then fold the angle in half. So as you can see, there's a square paper right here. And then you're going to fold a corner in half, so from this corner to there. And then when you unfold it, you find that the crease divides the angle. So angle is this angle or this angle right here into 2 angles. What is the relationship between these 2 new angles, and how do they compare to the original angle? Are there any special relationships? As you might have noticed the following observations. And that is the definition of an angle bisector. So you might see that there's an angle, and then after you fold that in half, that original angle was split in half. So that means that these two angles are each are one half of the original angle, and there are exactly two of them to make up to that, and they are exactly the same. So the definition of an angle bisector is that a ray from the vertex of the angle divides the angle into two equal angles. This ray right here is called the bisector of the angle. So this ray coming out from O, splitting this angle BOA into two halves. This ray is called the bisector of the or a angle, bisector of the angle. So here's the geometric lingo, or the language of the geometry. Lingo means language. Because OC is an angle bisector of angle AOB, so angle AOC is equal to angle A is equal to angle BOC, which is equal to 1/2 of angle AOB. Or angle AOB is 2 times the angle BC, which is equal to 2 times the angle AOC. Pause and think about this for a moment. You might want to jot these definitions down on your notepad. So it's saying an angle bisector is basically there's an angle and then there's a ray coming out from that vertex, splitting that angle into two smaller but equal angles, and that ray that splits it is the bisector of the angle. All done? Okay, let's move on. Example 2. As shown in the picture, the known point O is a point on line AB, and OM and ON are the bisectors of the angle AOC and angle AO and BOC. Find the degree of angle MON. I'll walk us through together. So, what's the question asking for? So we know that there's a line AB, and O is a point on it. OM and ON are bisectors of angles AOC and angles AOB. So we're trying to find the degree of angle MON. Well, let's think about this for a moment. The analysis here is to first determine the conversion problem of angle MON. Angle MON is equal to angle MOC plus CON. Combined with the angle bisector theorem, you get angle MOC plus angle CON is equal to 1/2 of AOB. So in the calculation of the angle, the geometric figure and the nature of the equation are used together, and the problem will be solved. So here's a solution. Because AOB is on the line, so angle AOB is 180 degrees. Because angle AOC plus angle BOC is equal to angle AOB, so angle AOC plus BOC is equal to angle AOB. So angle AOC plus angle BOC is equal to 180 degrees. And because OM and ON are the bisectors of angle AOC and BOC, so angle MOC is equal to 1/2 of angle AOC, and angle CON is equal to 1/2 of angle BOC. So angle MOC plus angle CON is equal to 1/2 of the sum of angle AOC and angle BOC, which is equal to 1/2 of 180 degrees, which is equal to 90 degrees. And because of that, angle MON is equal to angle MOC plus CON. So angle MON is equal to 90 degrees. The main idea of the lesson today was about comparing angles, and we learned all about the comparing sizes of angles, which was measuring directly and stacking figures, and the angle bisector theorem, the nature of an angle bisector, and angular calculation. And what were some of the skills we learned? Well, the first skill was knowing how to compare angles and estimating them, and learning how to use the angle bisector theorem to solve angle word problems. I hope you enjoyed this lesson today, and in the next one, we will be wrapping up this unit, and you'll be getting ready to dive into chapter 5.